Since the periodic table is based largely on electron arrangement, we can use it as a guide to help us figure out the electron configurations of most atoms without having to resort to rote memorization. The first thing we'll do is split the table up into 4 blocks. The alkaline earth metals are called the S block. The rest of the main group elements are the P block. The transition elements are the D block. And the intertransition elements, the F block. Now, since helium has been placed over at group 8 with the other inert gases, this method doesn't really work until you get to period 2. So you do have to remember that the filling order starts with 1s, but hopefully you learn that pretty quickly with a little bit of practice. Now, starting with period 2, as you make your way across each period, remember these correlations. First, as you go through an S and P block, the N of your subshell is equal to whatever period you're going through. So going through the second period, we're going through the S block, 2s, and the P block, 2p. Now we go through the third period, 3s, 3p, and starting the fourth period, we go through the S block, 4s. When you go through the D block, remember that the N is equal to the period minus 1. So we're in the D block of the fourth period, so it'll be 3D. Now we go back through the P block, 4p. Going through period 5, it'll be 5s, 4d, 5p. Now we're going through period 6. Again, starting with the S block, 6s. But at this point, don't forget that this is where the F block has been pulled out from the main body of the periodic table. And when you go through the F block, the N is equal to the period minus 2. So the first row of the F block is part of period 6, so that'll be 4F. Now we go back through the D block, 5D, then through the P block, 6P. Period 7 is the same way, 7S, 5F, 6D, and 7P. And there you have it. There's our filling order from 1s to 7p. And there's other things we can get from the periodic table about electron configuration than just the filling order. For example, notice there are 2 groups in the S block to remind us that the S subshell can hold up to 2 electrons. The P block is made up of 6 groups. That reminds us that the P subshell can hold up to 6. The D block has 10 groups, which equals the number of electrons that the D subshell can hold. And the F block has 14 groups, reminding us that the F subshell can hold up to 14 electrons. Finally, an element's location in the periodic table gives you a clue about how the electron configuration should end. Take oxygen, for example. Its electron configuration is 1s2, 2s2, 2p4. It's in the second period, and it ends with the second shell. It's in the P block, and it ends with a P subshell. Not only that, it's in the fourth group of the P block, and it ends with P4. So let's take everything we've learned about electron arrangement in the periodic table to predict the electron configuration of iron. Iron can be found in the 6th group of the D block. So based on what we just said, its electron configuration should end with D6. And it's in the 4th period, and remember when you go through the D block, the N is equal to the period minus 1. So its electron configuration should end with 3d6. Our first 2 electrons will go in 1s, and from there we can use the periodic table to guide us through the rest of the configuration. Starting with period 2, we'll go through 2s and 2p, and remember there are 2 groups in the S block to remind us that it should be S2, 6 groups in the P block to remind us it should be P6. Going through period 3, it'll be 3s2, 3p6. Going through the 4th period, 4s2, and that leads us through to the D block, where we've already said the configuration should end with 3d6. Now, it should be mentioned that not every element on the table can be predicted using this method. Some elements have what we call anomalous configurations, which means their actual electron configuration doesn't quite match what we otherwise predict. However, by and large, the big majority of elements on the table, especially the ones you encounter in a general chemistry class, have electron configurations that can be predicted using this method. So once you understand how electron arrangement and the periodic table are connected, it gives you a really good way to predict electron configurations, and hopefully one that'll be easier to use than just rote memorization.